Cool. So welcome to the final exam review. We're going to go until 11. I'll answer pretty much any questions, but if someone asks the same question more than once, or if I hear the same question more than once within a few minutes, or something that I can refer back to, then I'll just tell you to go and watch the recording because this is being recorded. So. I have a couple of questions that were asked already. Maddie asked, can I go over the Gardner trial results? And yes, absolutely. So the Gardner trial was the high fat, low carb versus high carb, low fat diet. And what I ultimately wanted you to take away from that was that there were no statistical differences between either of those diets, and that both lost weight. So that's important. Both lost weight, but there was no difference between them. So what you can kind of say is that both work, which is kind of what we've learned in class is that it's about what allows the diet to be sustainable. That was something that was characteristic of both of them. They both were flexible. So the main thing that you need for points, though, is just to ensure that you know that both diets worked and they weren't different from one another from a statistical perspective. Did that answer your question, Maddie? I'm assuming it did, but let me know otherwise.
Yes, thank you.
Cool. Yeah. And for everyone else, ask away. What the short answer questions will be, yeah. Um, there's the creatine question, the one that essentially there was a quiz in class for extra credit. And you're just going to need to know the quote unquote equation in which creatine phosphate helps contribute towards ATP production. And the main idea is that you have creatine phosphate that's stored in the muscle, creatine with a phosphate group attached to it. And when we're burning through ATP, we're going to be essentially breaking that bond and uh, utilizing that energy from ATP. And what we're left with is ADP, adenosine diphosphate. So we have adenosine diphosphate, which is two phosphate groups, and we have creatine phosphate, which is stored in the muscle. All we have to do is move that phosphate over from the creatine phosphate to the ADP, and now we've recycled and gotten back to the fuel that we want to use, which is ATP. Or I should say the energy currency that we want to use. Um, so you're just going to need to know ADP plus creatine phosphate, and then it's a bidirectional arrow, which means it actually works both ways, results in the production of ATP on the other side and a lone creatine. So creatine without a phosphate group attached to it. So just make sure you know both sides of that equation, the fact that it's reversible by demonstrating that it's an arrow that goes both directions, and then the enzyme that does that is creatine kinase. Other short answer questions, the Gardner trial, which I already talked about. Um, oh, ketogenic diet question. So why would a ketogenic diet not be appropriate potentially for a lot of different athletes? If you keep in mind the image or the figure that you're going to be labeling, which is the energy pathways figure, you'll see creatine phosphate or the ATP-CP system is contributing towards ATP production within the first 10, 15 seconds or so. As it starts to drop off, you're going to see glycolysis increase, and that's going to uh, last you until about 90 seconds or so, where the aerobic system is kind of already ramped up by that point, contributing up until the larger time frames in which you can do aerobic types of exercise. So um, two of the fuels, or I suppose knowing the fuels there will help. Creatine for the creatine phosphate ATP pathway, that is a given. Glycolysis is going to be muscle glycogen for the most part, but if you said glucose, I wouldn't argue with that. And then the aerobic systems are going to be carbohydrate and fat, whereby that distribution of carbohydrate and fat is going to be dependent on the intensity and the duration of the exercise, where higher intensities mean more carbohydrate utilization and less fat. And that ties into duration because usually higher intensity exercises are going to be, or activities are going to be lower or shorter in duration. So relaying it back to the why the ketogenic diet is not appropriate for a lot of athletes, it's because two out of those three pathways, glycolysis and the aerobic pathway, are utilizing glucose. So if someone is doing a ketogenic diet, they are purposefully excluding glucose from their diet. And so you're getting rid of or severely reducing the amount of fuel that is available for ATP production. That one was a long one because I also wanted to incorporate multiple questions into that so that I could refer you back to it if I need to. What other questions? I'm going to keep it kind of general on one thing. A lot of the questions from your previous exams, I think you should be familiar with. So the red wine question from exam one, whether or not that is a practically healthy thing for people to consume relative to other types of alcohol. The omega-3 question, where we were looking at why fatty fish, are specifically a better source of omega-3s than something like flax seeds or other plant sources. That's another one that you're probably going to be aware of or going to want to be aware of. Let's see what else. I can pull up the exam too, just to make sure that I'm getting everything in there. I feel like there's something that I'm missing. Okay. So yeah, a few of these written questions are actually going to be extra credit. So I'm not going to tell you which ones per se from previous exams because I kind of want you to prepare appropriately. But you should be prepared for the red wine, for fruit sugar being good or bad for you, and why or why not. The omega-3 question, the Gardner trial one, ketogenic diet. Actually, yeah, I covered all of them. I guess it depends on whether or not you think that the creatine reaction is actually a short answer or not, because you could write it out, but really what I need you to do is just show me the different portions of the equation. So, yeah, hopefully that answers that question. Shazia asks, what minerals and vitamins should you know? You should generally know which ones are water soluble and which ones are fat soluble. And then, especially for the fat soluble ones, I want you to understand primary functions and, yeah, essentially primary functions that we've discussed. I would probably want you to be aware of what could happen if you get too much or too little, specifically of those fat soluble vitamins. With the water soluble ones, I'm not going to focus a whole lot on them, except for maybe the folate B12 B6 interaction, which relates to the whole idea of the methylation or that transferring of that carbon that allows different things to be produced, like epinephrine, um, the actual gene expression. The example that I used was kind of like smothering the DNA and allowing it to either express or reduce the expression of certain genes and the proteins that they would produce downstream. Um, Folate B12 and B6 also contribute towards DNA synthesis. So helping with things like red blood cell production is a really key component because in order to make new red blood cells, which we know are important, we need to have adequate amounts of those DNA components to be able to do that. Minerals, iron, zinc, sodium, potassium, chloride, some of the ones that are pretty niche, right? So like phosphorus and like selenium and all that. I wouldn't really focus on, but like you should know about calcium. You should know about sodium, potassium, specifically with sodium, potassium, other than the function. You should know the AIs for it because I did emphasize that in class, 2,300 milligrams for, or sorry, 20, 23, 20, 23, 26. Oh gosh, blanking on that one. Can someone confirm that for me really quick? I believe it's 2,300 and then 4,700 for potassium. Those are the two AIs that you should know. I mean, honestly, if you put like 2,000 something, I'm probably not going to mark you down on it. Um, what else? Zinc, the immune functions, and as a cofactor, iron, you should know functions of iron. So relating to hemoglobin, specifically, its role in blood. um, you should know the different forms, so ferric versus ferrous, and which one is more optimal for bioavailability purposes, which one can we absorb easier, which would be the heme form, the Fe2 plus form, which is also what we would find in animal sources. Um, the plant source Fe3 plus or ferric iron would be less absorbable. Now, I mean, you can do things like adding citric acid, like lemon juice or lime juice or something like that, and that would actually convert the Fe3 plus into the Fe2 plus. But I'm not going to have any questions about that. Um, I think in general, you should know that I'm not going to go into super specific details about things unless I made it a point to mention it in class. Um, like I wanted to do my due diligence and make sure that you know what all of the vitamins and minerals do, at least to a certain degree. But I'm not trying to be mean in terms of giving you super niche functions of a lot of these things. Antioxidants is something you should be familiar with as well, right? Primary water and fat soluble antioxidant. Hopefully that answered that question. Like I'm trying to be vague enough so that you don't just study super specific things and don't get anything away from any of the general functions. But I'm also not trying to, um, I guess what I'm trying to say is I'm just trying to make sure that you have a general understanding of everything, but you're also prepared for the exam. You're welcome. 2,300 milligrams of sodium, right? Anyone else? Questions? Questions? I know it's that time of the semester, isn't it? 2,300 and 4,700. Okay, I had to check just to make sure. There is a matching section. It's about the vitamins and the minerals. Different components of the female athlete triad. So you should know which portions are or are not the female athlete triad, and be able to differentiate it from, something like general relative energy deficiency in sport. And just so you're aware, for female athlete triad, it's low bone density, low energy intake, and loss of the menstrual cycle, otherwise known as amenorrhea. TS, what are the components of daily energy expenditure and details for each? Yeah, so total daily energy expenditure is basically all of the calories or the energy that you burn in a day. I'm never going to ask you specific percentages because it's a range, but the primary portion that makes up your total daily energy expenditure is your basal metabolic rate. So your what I used to call your coma calories, right? The stuff that's use just to kind of keep the lights on, breathing, heart pumping, brain firing on all cylinders sometimes, right? And then you have physical activity, which can be broken down into purposeful physical activity like exercise. We can also break it down into neat, non-exercise adaptive thermogenesis, which would be things that you're doing throughout the day that aren't intentional exercise. You could do gardening or walking from class to class. It kind of depends on if you view that as exercise, but it could even be something as simple as like you sitting in your chair. You're still burning more energy sitting in a chair because of the postural muscle components than you would be if you were laying down, as long as that makes sense. And then you have the thermic effective feeding, which is the kind of the cellular energy that we expend just to be able to utilize fuel. To some degree, it's kind of an investment. So fat, if we had an excess amount of fat, we wouldn't have to do very much with it because it's already in this form that we can very easily store, relatively speaking. Carbohydrate would be the next lowest or highest, depending on how you view that with a thermic effective feeding. And then protein would be the highest in terms of how much heat it's producing. So that's kind of what I was getting at is that the more effort we kind of need to put into converting these different sources of fuel, the more heat it's going to inadvertently produce, um, which is kind of like if you've taken chemistry, you'll know that that's the law of oh gosh, entropy. Things kind of just like spiraling into spontaneous chaos. But in from an energetics perspective, it's this inevitable production of heat with energy metabolism. Say hi, dog. Yep. Anyone else? Yep. No mic today, Tia.
No, I'm actually online shopping right now, and I'm like half in this conversation, so
Wow, that's a great thing to have on a recording. Thank you.
yeah, no, you're welcome. I'm sorry.
That's okay. I don't care.
What's the phytochemical functional food and CAM definitions?
Yeah. So CAM is complementary alternative medicine. The idea is that like nutritional methods can be complementary, so they can actually like facilitate or be something that we can add on to existing therapies. So for instance, let's take like type 2 diabetes. You can be medicated for type 2 diabetes, but you could also, a complementary alternative stuff would be like the complementary could be exercise and, changing your diet. It could also be taking something like a supplement, right? So we learned about how chromium can help with the insulin receptor. Those would be complementary, so done alongside. Alternative would be doing those things instead of medication. So that's pretty intuitive once you kind of know what CAM stands for. The phytochemicals in functional foods. A functional food is essentially a food or a drink that we consume that has benefits outside of just providing energy. So, like for instance, coffee has, I mean, it has water in it, but it has caffeine in it, which can be beneficial for, like cardiovascular health and weight management. But even more so, there are compounds in that coffee, plant compounds, which we call phytochemicals, phyto meaning plant, right? That have benefits that could do anything from, like help stimulate metabolism to help promote antioxidant defense systems. An example of that would be red wine, right? That resveratrol that's inside of red wine is a phytochemical. Now, like we know that because of that first exam that there's not practically enough in there, but in something like coffee or green tea, there are enough of these antioxidant producing and supporting phytonutrients that actually can provide benefit outside of just a little bit of caffeine and some fluid.
Okay, thank you.
Yeah.
Dr. Meche, can we go over the question that says, what is hitting the wall and what likely causes it?
Yeah, of course. So hitting the wall is something that happens a lot with endurance sports. So usually if you're out there and oh gosh, the time frame kind of depends on a lot of different things, like how much fuel you've had beforehand and how long the exercise is. But usually, like if you're out there doing any meaningful type of endurance exercise for an hour plus, something that needs to be considered is this idea of if you're not taking in extra fuel, specifically carbohydrate, your liver glycogen can become depleted since that is your kind of overall store of or storage form for maintaining blood glucose. So if you remember, the whole purpose of glucagon was when blood sugar is low, the this pancreas will essentially tell the liver to break down its glycogen stores to release glucose into the blood. So basically, you're using carbohydrate while you're exercising. You're going to need to break down glycogen to provide the blood and the body, so to speak, with carbohydrate. So hitting the wall is this phenomenon where you're out there and you're exercising for long periods of time. And it's been going on long enough where you have depleted all of your liver glycogen. And actually, that goes back to that question about like different fuels that we use and the time course for them, because the aerobic pathway does utilize both carbs and fats. And so when you run out of liver glycogen, essentially that hitting the wall phenomenon is you're essentially depleted of one source of fuel that you would be using for that activity. So you go from having two sources of fuel to one, and that's going to feel like all of a sudden you've just hit a wall with your ability to continue exercising. That was a long answer to your question, but I was also trying to relate it back to other questions.
Thank you, made sense.
Yeah, good. I'm glad.
Can we also go over the other question that states what is the difference between a health claim and a structure function claim?
Sure. A health claim is something that generally has evidence substantiating it. So if you look at like Cheerios or oatmeal, it'll say that it can lower your cholesterol. That's because there's been data that has substantiated that the soluble fiber inside some of these like higher fiber types of like breakfast grains can actually decrease the amount of cholesterol in like a patient's blood, because it's usually what the studies are done in is patients like that. A what was is it was structure function health claim and structure function. So the health claim is the more supported one. The structure function claim would be much more general. So it'd be like helps manage your weight or something like that. So it's a much more general statement. And that's because there is no evidence for it, or at least there's weak evidence. So with the health claim, it is evaluated by the FDA, whereas the structure function claim is not. So I guess it's more like the strength of the statement that you're making towards advertising the food.
Thank you.
Uh-huh. Aaron asked, can we go over the crossover concept? Yeah, so I did mention it before, but I'll touch on it really quickly right now. And that's just the idea that depending on the intensity of whatever activity that you're doing, you're eventually going to see an inverse relationship with the proportions of carbs and fats that you're using. So as intensity increases, the proportion of fats is going to decrease, and then the proportion of carbs is going to increase. And that crossover concept is literally describing that intersection where we see that um, inverse relationship, kind of like that turning point, so to speak. Mm-hmm. Good. Any more? I mean, I
Um,
guess that's a good thing if y'all don't have too many. Yeah, go ahead.
could you go over the what metabolite do all macronutrient pathways converge at?
Yeah. So I guess what that question is really asking is if you were to break down all three types of fuels, so fats, carbs, proteins, eventually, we know that it's not just like, oh, carbs burn. It needs to be like broken down into many different steps, and that's true for all three of them. And the point where they all kind of intersect is right at the mitochondria, and that metabolite is called acetyl-CoA. And that acetyl-CoA are these little two carbon chains that go into the Krebs cycle, and they help make the whole electron transport chain work down the line. So yeah, acetyl-CoA, you'll remember when we talked about beta oxidation, you're taking long chains of fatty acids and chopping them up into two carbon units. Those are acetyl-CoAs, but also carbohydrate goes to that. That's in what we would call aerobic glycolysis, which is kind of not an accurate term, but it's just glycolysis that happens with an abundance of oxygen present. That pyruvate at the end of glycolysis gets converted into acetyl-CoA. And then there's pathways by which amino acids can be converted into acetyl-CoA as well.
Thank you.
Mm-hmm. Nazith asks, "What does muscle tear? Do muscle tears cause muscle soreness?" Yeah, small muscle tears do. Yes, I mean, I guess like literally a strain or a sprain could cause that as well. It's more of an injury. Muscle, like micro tears in the muscle, are what cause that soreness 24, 48, sometimes 72 hours after exercise. The part where it's hard to like sit and get off the toilet kind of stuff. Um, the main root of that question, though, is does lactate cause that? And that's no, it does not. Lactate is a fuel that we use. Mm-hmm. Any more?
So lactic acid doesn't cause muscle soreness?
Correct. And if you want to get even more specific, technically the human body doesn't have lactic acid. We do very briefly, but it dissociates very rapidly into lactate.
Could you go over the recommended sports supplements?
Yeah. Um, for endurance sports, it would be bicarbonate, which is baking soda. There's another one called beta alanine. The beta is the little Greek symbol. And it's basically like both of those function to be able to reduce acidity either in the blood or the muscle. And because we know that acidity or hydrogen ion accumulation in the tissue, like the muscle, for instance, can cause fatigue to occur. So by getting rid of that acid by using things that can actually buffer out or neutralize from a pH perspective, that acid, we can continue exercising for longer. For high intensity stuff, you can also talk about creatine. Um, Creatine, we've talked about how it works, but basically what it's doing is that creatine largely is inside of our muscle, our skeletal muscle, and it can recycle, for lack of a better term, ATP so that we can continue to both go for a little bit longer on the high intensity perspective, but also providing more energy for that period of time in those intensities. Um, there's also caffeine, which has been noted for both. And for aerobic, there's also I forgot to mention nitrates. So nitrates would be like if you remember back from when we were discussing um, arginine in the amino acids protein chapter. Arginine supports the production of nitric oxide, which can dilate your blood vessels, which can help with blood flow delivery. So that can be consumed either from plant sources, beets, spinach, things like that. Arginine was one of the ways to get that. It's not super efficient, but we did talk about that. And then there's other supplements, things called like citrulline, which is CITRULLINE. I don't think that shows up on your exam, but they're all basically ways to get to nitric oxide production. Also know that creatine isn't a steroid, anabolic steroid.
Thank you.
Mm-hmm. I guess it's worth mentioning my goal with that question was not to like make you memorize a bunch of sports supplements. It was more so to make you aware of which ones are actually supplements and which ones are like performance enhancing drugs. Lori asked, can I review the digestion routes of vitamins? Yeah. So fat soluble vitamins are like fats themselves, and they can't just float around in the bloodstream. They can't float around in fluid spaces because they are going to be incorporated with fat because they're fat soluble. So fatty acids bound up together in triglycerides, and those are all going to be within the vessel of a chylomicron if they're dietary. So just like dietary fats from the last exam or chapter, what was that, chapter 5? They're going to be incorporated into that lipoprotein vehicle called the chylomicron, and that's going to, after being packaged into it in the enterocyte or the intestinal cell, it's going to go into the lymphatic system. Where after that, it's going to go out into the rest of systemic circulation. Water soluble vitamins are much more straightforward. They're like carbohydrates and proteins that they go into the bloodstream afterwards. They don't, because they're water soluble, they are fine being in those fluid spaces. TIS, I answered that question already, so just make sure that you go back, but it's acetyl-CoA. What else we got?
Is the higher iron forms like for pregnant people?
Hmm. Yeah, I forgot to mention that, so thanks for bringing that up. So iron specifically is one of those ones that could be required in higher amounts for athletes because of the needed basic like building blocks to help create hemoglobin, but also in pregnant women and menstruating women. So in menstruating women, females need more in general, like double than what males need because of the, around once a month menstruation that causes the shedding of that lining, and then you lose a lot of blood that way. So needing more iron to be able to kind of replenish some of those stores. And then for pregnant women, it's because when females become pregnant, they have a large increase in blood volume. So very similar to the athletes in that scenario, you need more of the raw material to help make more blood. From the athlete's perspective, you should probably know vitamin D and calcium are good ones as well because of the compression and the extra calcium and the vitamin D to regulate it, necessary for, increasing bone density.
Okay, thank you.
Mm-hmm. I'm going to say it again. Yunuen? Yes, yes,
Yunuen, yeah.
yes. Cool. Wait, did I say it right? Or are you correcting me? Both.
Maybe a little
Okay.
bit of both.
Okay, cool. Got it. Well, I got one more shot. Can I explain the difference between trace and major minerals, if not already mentioned? Yeah, I don't think I mentioned it yet. The main difference is that they're both necessary, like they're both essential from a definition perspective. They're essential nutrients. The only difference is the quantities. So major minerals are generally needed in like milligram amounts, or sometimes a little bit higher. You could say that like sodium being 2,300 is the same thing as 2.6 grams, right? But trace minerals are needed in much smaller amounts, micrograms a lot of the times. So that's essentially the difference between them is just the necessary function or the necessary quantities. I answered like the water soluble vitamins things already for the ones that you need to know, but the one that I probably will emphasize is vitamin C is your body's primary water soluble antioxidant. Um, Whereas like the sub form of vitamin A, beta carotene, and vitamin E are the primary fat soluble antioxidants. I mentioned like B12, folate, B6 contributing towards methylation, like gene expression, creation of things like epinephrine, but also red blood cell production. But I went into more detail of that at the beginning.
What are the electrolyte RDA amounts for sodium and potassium?
Yeah, I mentioned that at the beginning too. So it's not RDA, they're AIs, the 2,300 and 4,700.
Oh, okay.
Mm-hmm. There's chloride, but I'm not going to make you memorize the chloride. Off the top of my head, it's like 2,000 or 2,100, but we don't really have trouble. We don't have any issues getting chloride in. And while we're on the topic, kind of like calcium, you should probably know that calcium is the body's most abundant mineral. Anything else? Got 9 more minutes. Any formatting questions?
Is there going to be any fill in the blanks?
Yeah, one of them is going to be the iron one, so you should know the different forms of iron, the ferric and the ferrous, and be able to not just know those names, but also be able to identify like whether it's the Fe2 plus, the Fe3 plus, and then what the sources are, animal versus plant. And the other one, I feel like there's one more.
Is there gonna be the wine question again on the J-shaped curve?
There could be.
Okay. Well, because I have it, it's on the thingy. It says ponder about previous questions you've had regarding red wine and fruit-derived sugar.
Yeah, what I'm trying to say is that it could be on there. There's a bunch of questions that were like short answers from exams 1 and 2 that I'm not going to tell you whether it's actually on the exam or not, because some of them are extra credit and some of them are not.
Ah,
Hmm.
okay. But
Yeah.
if I like go back through that assignment, I that's a good kind of guide
Yeah,
for
for
my,
sure.
okay.
Yeah. I mean, I'm not gonna like take new questions from those assignments.
Okay, that's okay. That really answers my question. Thank
Yeah.
you.
Like for that assignment, what was that podcast one? I'm not gonna like take the what are the hangover neurotransmitters. I'm not gonna pull anything else from that.
Okay. And then what about general consumption principles? Is that just like my plate stuff?
Yeah, it's really hard to like put that into a note on a study guide. It's more so like, hey, what are the things we eat too much of? What are the things we don't eat enough of? What are the general like recommendations, right? So like lower your sodium intake, your sugar intake, your trans fat intake. What are you trying to increase? You're trying to do the my plate, like you were saying. So incorporating grains, but not just any grains, whole grains, and you want more fruits and vegetables, and you need want some, it's like all those things that it sounds like a lot when I'm just listing them off, but I would say like even someone who's never taken a nutrition class, a lot of that stuff is pretty intuitive already, right? Like increase your fruits and vegetables, decrease your salt intake and your saturated fat intake.
Yes.
Yeah, good question though.
Thank you.
Hmm. Oh, the other fill in the blank one is the exercise recommendations, the ACSM recommendations, the 150 minutes of moderate intensity versus the 75 minutes of vigorous intensity exercise.
For lipoproteins, is it just remembering what LDL and HDL do?
I mean, I would be familiar with all four again. Chylomicron, VLDL, LDL, HDL, and then what they're like comparing and contrasting them, right? So LDL and HDL serve opposite functions in terms of cholesterol delivering, I suppose, or cholesterol transport is probably the better word for it.
Right.
They're primarily cholesterol, whereas chylomicrons and VLDLs they're both going out towards the rest of circulation to tissues, but one's coming from the diet, whereas the other one's coming endogenously from the liver.
Gotcha. Okay, thank you.
Yep. Any more?
What percent age loss detrimental effects begin for
Oh, yeah. It was meant to say percentage, like percent edge, not like percent
age?
age. Yeah, yeah.
Okay.
My bad. It is 2%. 2% is where you start to see the negative effects of dehydration.
So I think you already said this because we've been talking about specific water-soluble vitamins, but is it just easiest just to know, all dogs eat kibble for fat and then water-soluble is everything else?
Yeah,
Okay, sweet.
much easier. There is a lot of extra credit on this exam. I think there's the potential for like 7 points of extra credit.
Okay, and for people that are at risk, or I guess populations likely deficient in fat-soluble vitamins, it'd be like obese people, people with liver and kidney disease, the elderly, people who live in dark places, and vegans.
Yeah. I mean, it's gonna kind of like I focus a lot on vitamin D, so know that one for sure. I think vitamin A. Yeah, I don't really talk about like deficiency because pretty much only vitamin D is a concern where we're at. Vitamin A, E, and K are relatively easy to consume in like a Western diet. But I would be kind of familiar with like the megadose symptoms, right? So like polar bear liver, increase of vitamin A could kill you, right? And too much vitamin D could start to create like calcium plaques inside of your soft tissues, like your arteries. And I don't really talk too much about like vitamin E in that sense, but like vitamin K, I would be aware of like, oh, that's the one that we make inside of us, and that's the one that we give to babies as a shot, and to make sure that they have the ability to clot and not internally bleed to death if there was some kind of traumatic event.
Okay, that makes sense. And that's like what you just summarized. I'll just go back through the slides and make sure that I put the details of each one on a flashcard. So,
Yeah, that's probably a good idea. Like I wouldn't I wouldn't go into like a ton of detail like vitamin E, if you are deficient in that, you're going to have hemolytic anemia. It's so rare that it's not really worth talking about. I mean, I have that question about like too much vitamin A in a polar bear liver, but that's just because I think that's a cool little Snapple cap fact for people to know and it
right.
sticks with you, right?
I'm assuming that's going to be an extra credit.
Could be. I got time for one more if anyone wants to fire one more off. And I'm sure you're studying for other things, but or maybe you've already had some of your finals already. But there's always the Monday one at 1 p.m. That's usually the one that more people come to. So, any last minute ones? Or are we good?
For muscular endurance, do you want the answer of repeating the same movement for a long duration or more so cardiorespiratory endurance?
I want you to be aware of what the different components of fitness are. And I mean, I guess it helps to know what they all are, but I'm not going to test you on the definitions of them. It's
Okay,
the idea is that you can separate which are and are not um, the components of fitness.
gotcha. Okay.
Yeah. Like we never talked about cardiorespiratory strength because that's not something that we measure, right? Hint, hint. Good. Okay. I'll upload this. Enjoy studying, everyone.
Thanks.
Yeah. Yay. Thank y'all. All right. I'll see y'all later. Enjoy your Friday.
Thanks, you too.
See ya.